6.5, we're going to look at solving equations that have exponentials and then solving equations that have logarithms. So let's take a look. Let's look at A first. We've got 1/2 e to the x equals 13. So before we get to do anything, the first thing that's kind of often in our way is that 1/2. So how are we going to get rid of the 1/2 first? Well, I can do that quickly by multiplying both sides by 2. That will get me an e to the x equals 26. Now, the question is, how do I get rid of the e in front of that e to the x so that I can just be left with the x? Well, remember, the only thing that's going to get rid of an exponential of e with your base of e is going to be its inverse, which is a logarithm base e. Well, what's the logarithm base e that we know about? Well, that's a natural log. So that will go in front of your exponential. But if you do it on one side, you have to do it to the other side. So we put the natural log on the left to get rid of the e. The natural log has to go on the 26 in front of it on the other side. So the natural log will get rid of the e on the left and will leave you with just an x because they're inverses. And on the right, you'll have the natural log of 26. And if they're asking for answers in exact form like they are on this one, we are done. We don't need to go any further unless they ask us to approximate using our calculator. We're just done. And be careful, if you're typing an answer like this into my math lab, when we type in natural log, you type in an L using your keypad and an N and then just the number 26. Be careful, that's an LN, not an IN. Let's look at B. On B, we have 5 to the x equals 13. So looking at solving this, the only thing that we're trying to get rid of is that 5 that's attached to my x. Well, that's an exponential function. So to get rid of it, only way to do that is with a logarithm with the same base. So I'm going to use a logarithm with a base of 5 as well. If I do it to one side, I've got to do it to whatever's on the other side, a log base 5 to the 13. So that will get rid of my log base 5 with my exponential base 5, leaving me with just the x on that left-hand side. But that gives me an answer of log base 5 of 13. Now, sometimes they're okay with me writing it like that. Sometimes they aren't. Sometimes they'll say I want ln's or I'll want log logs. Remember, if you want either ln's or log logs, if they're forcing that on you, or if they want you to use your calculator to figure out what this is as a decimal, then there is no way around it. You'd have to use your change of base formula. So if they ask for, let's say, log logs, you could rewrite it as an log log. Remember, the change of base formula says to put the base, the 5, on the bottom. So we put the 5, the base, on the bottom. And then the 13 would go on top. So if you were doing this in your calculator, you'd type in log 13 over log 5. Now, sometimes they'll be okay with the log base 5 of 13. Sometimes they'll want you to use the change of base. You need to read the problem. Let's look at problem C. In problem C, we have 5 times 10 to the 3x minus 4 equals 6. So let's treat this like we would a normal equation. Well, the first thing is I can't even get to the x's yet. Well, I need to get rid of that 4 first. That's dangling off to the side, so we'll add 4 to both sides. That's a good start. So what that does is that will get rid of my 4's and move them to the other side. That leaves me with 5 times 10 to the 3x equals now a 10. Again, I can't get to that 10 even until I get rid of this 5 out in front. The parentheses mean they're being multiplied, so to get rid of it, I'm going to do the opposite. I'm going to divide by 5 on both sides. Well, that will get rid of my 5 at least. That now gets me let's see, 10 to the 3x equals, on the other side, let's see, I've got 10 divided by 5, which is just, let's see, 2. Almost there. Be careful. This is an exponential. We've got a base of 10, and we've got an exponent of 3x. You can't just divide by 10. How you're going to get rid of the 10 is by realizing you have an exponential. So how do you get rid of exponentials? Is with the log with the same base. Well, you've got a base 10. What log is going to get rid of a base 10 is an LOG log, because that's automatically base 10. If I do it to one side, I've got to do it to the other side, though, to whatever's over there. So what that does is it gets rid of my LOG log with the base 10, because they're both the base 10, and it will leave me with a 3x on the left-hand side equals log of 2. Last thing that we would do is get the x by itself. We'll divide both sides by 3. And that gets me that x equals log of 2 divided by 3. Be careful. It's understood if you were to figure out what this was as a decimal that you need to figure out what log of 2 is first. Then take that answer and divide by 3. This is not the same as doing the log of 2/3. You've got to take the log of 2, then take whatever that is and divide by 3. That's what your answer is. Or another way of rewriting this is basically 1/3 log of 2. The division by 3 is not inside of the log. In other words.